All right, this is example number 8 from section 7.6. This is the fourth example of Gauss-Jordan elimination by a system of two equations and two unknowns. So sometimes you hear it referred to as a 2x2, or it's a 3x3 matrix. It's going to have 2 rows and 3 columns. We're going to go ahead and look at number 8 here. It's 2x minus 3y is equal to 12, and 6x minus 9y is equal to 10. This is pretty similar to the previous example. If you notice the left side of the equations there, the second equation is just a multiple of 3 of the previous one. However, the 12 and the 10, they're not multiples of each other like the left-hand side. So something else is going to happen here. So we're going to go ahead and draw our procedure over here. So we want a row, in row 1, column 1, we want a 1. In row 2, column 1, we want a 0. In row 2, column 2, we want a 1. And in row 1, column 2, we want a 0. So that's our procedure we're going to follow for the Gauss-Jordan elimination. And go ahead and write in our augmented matrix here. And so the first order of business is we want a 1 in row 1, column 1. So if we want to make a 1, we're always going to divide by whatever this number is that we want to change to 1. So we want to change that to a 1. So we're going to divide by 2. More formally, that would be multiply by 1/2. So 1/2 row 1 replaces row 1. Or if you want to, you can say row 1 divided by 2 replaces row 1. And that would be totally fine too. Now we're not using row 2. We're not replacing row 2. So row 2 is row 2 as 6, -9, and 10. Now we're going to take row 1 and divide each term or each element of the matrix by 2. So 2 divided by 2 is 1. -3 divided by 2 would be -3/2. Or it's a nice decimal, nice terminating decimal. You could write -1.5. I prefer to leave it as the fraction. And then 12 divided by 2 is 6. So that completes the first step of the Gauss-Jordan elimination. Now we would like to make row 1 column, row 2 column 1. So we want to make row 2 column 1, that's 6 there. We want to make that as 0. So because that's in column 1, we're going to use row 1. So we're going to use row 1, and we're going to multiply row 1 by the opposite of this number here, which is 6. So we want to make the 6 a 0, so the opposite of 6 is -6. So we're going to multiply row 1 by -6, and then we're going to add that to row 2, and that's going to become our new row 2. So -6 row 1 plus row 2, and that's going to replace row 2. So 1 times -6 is -6. -3/2 times -6, we'll go ahead and do that off to the side here. So -6 times -3/2. So -6 over 1, just make it a fraction so we can multiply straight across. -3/2. So -6 times -3 is positive 18. 1 times 2 is 2. And then 18/2 reduces to 9. And then -6 times 6 is -36. Row 2 is 6, -9, and 10. So we're going to add that. So -6 plus 6 is 0. 9 plus -9 is 0. And -36 plus 10 is going to be -26. So row 1 is unaffected. We did use row 1, but it's unaffected. So row 1 is 1, -3/2, and 6. And row 2 is 0, 0, -26. Now remember, each row represents an equation. So the bottom row is 0x plus 0y is equal to -26. So this is 0 is equal to -26, and that's a false statement here. And so this is going to be no solution. If we were to graph these lines, they would be parallel lines. Okay, so these would be parallel lines if we were to graph them. Okay, that's it for this video, and we'll see you next time.